My name is Giridhar Reddy. My registration number is 17BEC0329. I am from C1 plus TC1 slot. My serial number is 5. If we talk about the block diagram of a microprocessor, which I have selected is IC8051, and we can see this is the flow chart and the block diagram of IC8051. Here we have port 0 drivers, port 2 drivers, and RAM, and port 0 latch, port 2 latch, and EPROM, and stack. We also have stack pointer, and we also main part ALU, assembly level unit, PSW, and we also have interrupt, serial port, and timer blocks, and buffer we have, and PC incrementer, program counter, DPTR, port 3 latch, and we have port 3 drivers, port 1 drivers. If we see, we can also have one more flowchart, and here we have interrupt control, and on chip ROM, on chip RAM, and CPU OSC bus control, and we also have 4 input output portals and serial port. Here we can see that these are the chip architectures of IC8051, and this is the DIP and PLCC. Here there is a instruction set of a microcontroller IC8051, and here we have the data transfer, and followed by some instruction which are as follows: MOV, MOVC, and MOVX, push, pop, and XCH, XCHD. For arithmetic we can have ADD, MUL, DAV, DEC, which is decimal, and like that. We also have similar for logical Boolean program branching. If you see here, there are some tabular columns which have the instruction and its description, and we also have the respective addressing modes of that instruction, and number of bytes and number of cycles. If we explain more detail about the microprocessing element or microcontroller of IC8051, IC8051 is designed by a company called Intel in 1981. It is a 8-bit microcontroller. It is built with 40 pins, and it has a DIP dual inline package, and 4 KB of RAM storage, and 128 bytes of RAM storage, and two 16-bit timers. It consists of 4 parallel 8-bit ports which are programmable as well as addressable as per the requirement. We also have one more flowchart. This is the pin diagram of 8051 microcontroller. Looks as follows, and here we can see and so many pins and it pin numbers, and this is the description of the each pin, and pins 1 to 8, 9, and 10 to 11 to 19. Like that, we have up to pin 40. And if we talk about the pin configuration, there's a input output pin, and talk about the port 0 and input configuration and output configuration. When the pin is configured as an output, then it acts as an open write. By applying logic 0 to a port bit, the appropriate pin will be connected to ground, and by applying logical 1, the external output will keep on floating. So we have here port 1, port 2, port 3 and their descriptions, and here we have pins current limitations. When pins are configured as an output, then the port pins can receive a current of 10 milliamperes. Here we have interrupt enable register, and it's a tabular column describing about the interrupt enable register, and we also have IP interrupt priority register and its description in the table column and the instruction. And we also have tcon register. Tcon register specifies the type of external interrupt to the microcontroller. So here are the features of the IC8051: 4 KB on chip program memory, 8-bit data bus, 16-bit address bus, and 3 internal and 2 external interrupts, 18-bit program counter and data pointer, 1 microsecond instruction cycle with 12 MHz crystal. Seisk and RISC have to do with design philosophy rather than raw counts of number of instructions. If we elaborate about the register organization of microcontroller C8051, the only register on an inside zone that is not memory mapped is the 16-bit program counter. Here we have the ports of descriptions like stack pointer, data pointer, program status word, which is in short known as PSW. Accumulator. This register is used by most instructions, and we also have B register. The type of algorithm used for signed and unsigned calculations are commonly known as addition, multiplication, etc. In Booth's algorithm, use a procedure for multiplying binary integers in signed 2's complement representation. Here we can see there is a flowchart of a Booth's algorithm how to solve on the instructions. Here we can start. A is and M is the multiplier and Q is multiplier. If Q0, Q minus 1 it will take. If it is 1 0, then it will go to A will become A minus 1. It is 0 1, then A will become A plus 1. If it is 1 1 or 0 0, then it will goes to the arithmetic shift, right? And count will be decremented. And if the count is 0, then it will end and it will give the answer. Similarly, we can see the division algorithm and its instruction how to calculate. If is a type of control unit used and correlated performance, type of control unit in model 3 as we talked in the computer organization architecture syllabus, and control unit, and it has flags, clocks, instruction register. We also have 805 memory organization, which is ROM, RAM, and stuff like that, and program memory, ROM, and internal data memory. Up to 256 bytes of internal data memory are available depending on the 8051 derivative. External data memory, we also have this. Access to external memory is slower than access to internal database. SF or memory, and we also have, there are two types of interfacing: partial decoding and complete decoding. Whether the process level parallelism is available in the element is selected. Handling a cache is the old way, like send the address, read operation to the next level of the hierarchy, wait for the data to arrive, update the cache entry with data, rewrite the tag, and reset the memory address. This time there will be hit. There are various get data before replace the block, send the requested word to the CPU as soon as it arrives at the cache, early restart. Request word is sent from memory first, and then rest of the block follows the request word first. Okay, this is the digital assignment one, and thank you.